Hello, so in this video we are going to be looking at geometric series examples. So the first one is we are given 3 plus 6 plus 12 and so on, and we are asked to find the sum of 15 terms of this particular series. So if you find the difference here, 6 minus 3, that will be 3, and if you say 12 minus 6, that would be 6. So obviously you do not have an arithmetic series, so we can get rid of this. So then we say 6 divided by 3, well, that will give us 2. 12 divided by 6, that will give us 2. So that tells us we have a geometric series. So because we have a geometric series, we can write Sn equals to A into r to the power n minus 1 over r minus 1. So we want the sum of 15. The first term is 3. R is 2 to the power 15 minus 1 all over 2 minus 1. So the sum of 15 is going to be 98,301. Moving to the second example. So in this particular case, we are asked to evaluate. Because this is a series, it means we must find the sum, but we are not told the sum of how many terms. However, we are given the last term. So that means, firstly, we need to identify what type of series we have. So if you say 9 divided by 27, so you are going to get 1 over 3. 3 divided by 9 is 1 over 3. So now we are sure we are dealing with an arithmetic series. And so you can say Sn equals to A into r to the power n minus 1 over r minus 1. Now in this particular case, we see that we do not know how many terms we are adding. So we need to go to the general formula, the nth term. So here we have 1 over 2,187 equals to 27 times 1 over 3 to the power n minus 1. You divide by 27 on both sides, you will have 1 over 59,049. This will be equal to a third all raised to the power of n minus 1. Now, because you have a base of 1 over 3, it's a clue that you must find. So this must be base 1 over 3. But your only question is base 1 over 3 raised to what? And it's raised to power 10. So you can do this by trial and error. Say a third raised to power 7. So if you are not getting this number, you move on to power 9 and eventually you will make it to power 10. So because the bases are the same, the exponents are also the same. So n is 11 because we transpose this minus 1 and it becomes 10 plus 1. So we come back here and say the sum of 11 is equal to 27. This is our first term. This is a third raised to power 11 minus 1 all over a third minus 1, sum of 11. Now, technically speaking, we need to use the other formula that says 1 minus r to the power n. But regardless, they both give the same answer, so we are fine. So once you have done that, you would be able to identify your sum. So moving on to the third example, the final example in this case, we are given the sum formula. So it says determine the sixth term of the series given this formula. So we can use the trick we learned when we were doing arithmetic series. So we say T6 is equal to sum of 6 minus sum of 5. So 20 over 3 minus 20 over 3 into minus half raised to power 6 minus 20 over 3 minus 20 over 3 into minus half raised to power 5. So term 6 is going to be minus 5 over 16. If again, I need to emphasize this, you need to plug all of this in your calculator at once. There is no need to do it bit by bit. Just do it all at once and you will get term 6 to be minus 5 over 16.